Yes.
Okay. Yeah. So please take 40 minutes, then 5 minutes is for question and answer.
Okay. Thank you. Thank you very much.
Okay, thank you. Please proceed.
Yeah. Thank you very much, Chairman. And it is my pleasure to be here in this conference because NEHU is just heart to my heart. And as we are for long association, we have a long association with NEHU. And today I shall talk on sustainable polymer and their nanocomposite for multifaceted applications. Now, all of you know that this sustainable development, sustainability is becoming a buzz phase. But believe me, it's not a buzz phase. It is the requirement of the day. It is the order of the day. As sustainable development is the development that meets not only the present generation, but also it think about the future generations need. And since 2015, when United Nations General Assembly adopted the development agenda that transforming our world, the 2030 agenda for sustainable development, its implications and importance become many full in this society. Thus, sustainable development is not a smart growth, zonal or local growth, and any techniques or tools which are devoid of the principle of sustainable development. Rather, it is more than the combination of economic issue, environmental issue, material issue, and human resource development issue. However, I shall be strict onto the material issue as a material scientist. The importance of materials, as you know, has been recognized or realized from the ancient time. And that's why a particular era has been named with the material which has significant contribution in that era, like Stone Age, Ceramic Age, Bronze Age, Iron Age, etc. And now we are talking the age of polymer. And over the last 2 decades or so, the materials like nanomaterials, which is I used to call is Lilliput, is coming into the picture. And hence you are able to see the applications of all these materials either individually or combination thereof in this modern society. Now, you may ask that why polymer I have chosen as the topic for this sustainable development. Polymer is the youngest member of the material family because it came lately in 1920 when Schrödinger has given the concept of polymer that it is not the association of polymer, rather it is a macromolecules joined covalently by the repeating unit, and the number of such repeating unit is so high that addition or subtraction of few such unit will not influence the ultimate property of this polymer. In fact, polymer is a wonderful material gifted by the nature because even though its realization has came lately, but polymer has started its journey since the day the living system come into exist in this universe. Because the fantastic combination of nitrogen, hydrogen, carbon, oxygen resulted this life system, and this biopolymer is an example of it. However, in the modern society, this polymer has been enriched by manifold by the effort of the scientists, and that's why all sphere of the applications of materials, you are able to see this polymer, and most of the other category of material have been replaced by this youngest member. The reason behind this are many. Some of them I have listed here, that a polymer can be obtained from different feedstock. Just to elaborate, say polyethylene, we need the ethylene monomer as the raw material. Now, ethylene monomer can be obtained from petroleum resource, coal, natural gas, but it also can also be obtained from agriculture product, forestry product. Say, for example, agriculture product, cane sugar industry, the molasses produce ethanol, which on dehydration produce ethylene. Thus, it can be obtained from different resources. Now, all these polymers are more than 99% of polymer are organic in nature. And as a chemist, we know that organic compound having different functionalities, which can be translate or transform into other functionalities, and result of which you can play around the structure. And playing around the structure, we are tuning the property, because structure and property are correlated very closely to each other. Through modification further, you can change its performance, its fabrication process, and hence a high speed mass production is possible, because the energy required for processing of a polymer is much lower compared to metals or ceramics. Just an example, iron need 1535 degrees centigrade to melt. Ceramics need more than 3000 degrees centigrade to process, whereas polymers, say for example polyethylene, it's required less than 200 degrees centigrade. And hence you can get a high speed mass production, and as a result, overall cost of these polymers are much lower. It is not its aesthetic appearance, the colorability. You can give whatever color you like. Multicolor is possible, whereas metals or ceramics you cannot. And most importantly, polymers are light in weight. So today's sophistication is due to this lightweight characteristic. Now, when you have so many advantage and cost is low, then what will happen? We will use them day in, day out, from the bed to the beds. And even at our time of suffering, when we have the problem, say, like if I have the problem with eyes, I can use contact lens, artificial heart, even different drug molecule, controlled drug delivery system, polymer is your friend. Even an ugly person can become beautiful by help of plastic surgery, where polymer will play a major role to do so. However, as you know, nothing is ideal. And hence, there are some problems with polymer too. And that's why when recklessly polymers are used, you are resulted environmental havoc, which I have shown in these slides. Not only that, synthetic polymer, which are mainly obtained from petrochemicals or fossil fuel, they have other problem too. They are depends mainly on fossil fuel, and as you know, that it is estimated that this fossil fuel fixed stock of oil reserves will be exhausted by 2050 if we have not taken alternative some resources. In addition to that, the synthetic polymer also has the solid waste disposal problem, landfilling problem, risks to aquatic and terrestrial animal, and overall adverse environmental impact of this polymer at the end of the day. Thus, if you go through all these problem, you will able to see that non-renewability of the raw material and non-biodegradability of the product are the major causes of all such problems. Then question definitely will be there, what are the right polymers? The polymers should be such which has low dependency on the fixed fossil fuel raw materials, so that depletion of petroleum or oil reserves can be prevented. It can be preserved for the future generation. This raw material must be environmentally benign, and polymers should be biodegradable. The development should be sustainable, as I have already informed at the very beginning of my talk, and this should be available easily. Handling and transportation should be comfortable, and most importantly, through this approach, we should get high carbon credit. I do not know whether you have the idea about the carbon credit, because the environment is already polluted. A lot of greenhouse gases are generated, and we have to mitigate all these greenhouse, particularly COX and NOx, to refresh our environment. And for this, carbon credit has to be earned. And one carbon credit means reduction of 1 ton of carbon dioxide production. Furthermore, the approach must follow the concept of triple bottom line, which is concerned about the society, ecology, and economy of the society. So literature advocates that the bio-based renewable raw material may be the right choice to obtain such sustainable polymeric system, because they are not only renewable, they are available easily in adequate quantity. They are environmentally friendly, biodegradable, and mostly are relatively low cost, easy can be modified and handled, and the existing knowledge of chemistry will help us to transform this bio-based raw material into the polymeric product which are happen to be sustainable. And this sustainability, you can see from this slide that if you can get the raw material like some fruit, oil from the plant, which on modification and polymerization process, you will get the product. And at the end of this product service life, this will be degraded or assimilated by the microbe to generate carbon dioxide, water, and biomass, all of which can be useful to the growth of the plant. And this cycle will be continued, and hence there will be no full stop, hence it will be a sustainable development. However, this process of transforming this bio-based raw material into the desired product must be simple, because I believe simple thing is the best thing. Nature produce all this product through a very simple route. Just an example, say natural rubber. Whether you are obtaining natural rubber in India, Brazil, or Malaysia, or Sri Lanka, all are same. Whether it is winter, whether it is summer, whether it is a rainy season, this production of this natural rubber will be the same in structure and stereochemistry. Even though in front of nature we are infant, but still we have tried to utilize this concept that through the simple modification, say vegetable oil can be converted to monoglyceride, which can be reacted with the anhydrate, epichlorohydrin, diisocyanate to produce the polyurethane, polyester, polyestyramide, epoxy, etc. Thus, our journey has started with the simple route. Now, along with this point, we also have to remember as a polymer scientist that architecture of polymer has a major role to play in its processing as well as in performance. Whereas most of the industrial polymers are linear in structure. Incorporation of branching, on the other hand, not only help in processing, but also it provides some special characters, some special properties. And thus, there are different types of highly architectural polymer like comb polymer, star polymer, brush polymer. However, we have the interest on dendritic polymer, which means tree-like growth and appearance. There are two types, either it's hyperpunch or dendrimer. Dendrimer are more perfect in structure, whereas hyperpunch accumulates somewhat defect in the structure. However, hyperpunch are more industrially important than the dendrimer, because this hyperpunch can accumulate some defect and hence they can be synthesized by a single step process, just like conventional industrial polymer. However, I urge upon you to see the nature. Nature produces many beautiful things like branches of trees, two wings of butterfly, and these are so symmetry, and not only symmetry, they can act very specific and effectively just like enzyme. To mimic this nature, we have synthesized hyperbranch bio-based polymer, because this hyperbranch polymer has large number of terminal functional group, and as terminal functional groups are effective for their functions, so you have very effective polymeric system. They also have globular and non-entangled structure until and unless you design to get entanglement. And also they have low melt and solution viscosity, high solubility compared to conventional counterpart. And all these are very useful for their ultimate applications. Thus, in our research, we have started our journey with hyperpunch bio-based polyester system, because polyester means esterification reaction is the simplest organic reaction, and polyester outrank about 54% in the coating and paint industry. In addition to that, polyester is also used as flame, it can be used as a fiber, it can be used to make foam, to make hot melt adhesive. So wide applications are possible from this polyester. So we have used different type of bio-based raw material like monoglycerides of the oils, dimer acid, glycerol, citric acid, tannic acid, starch, and to get the hyperbench polyester system. However, you have to remember that polyester, as this ester linkage, are vulnerable to the alkali. And when you need the alkali resistance, these are not the polymer. Hence, to improve its performance, we have given a marriage between the ester group to get the flexibility and amide, because amide group is very strong alkali resistance, and you will get tough material. So if you can give a suitable marriage between the ester and amide to produce a polyester amide system, then you will not only get the flexibility, toughness, alkali resistance, but also it will provide the biodegradability. However, our main research focus was on hyperbranch bio-based polyurethane, because polyurethane is the most versatile polymer because of its inherent soft and hard segment in the same structure, and this heterogeneity or inherent, and hence you can play around its structure by controlling the hard and soft segment structure position, and hence you can play around the property and its case. Thus, most of the polymer or rather products are obtained from these patents, and that I shall discuss a later part of my lecture. Another polymer industrially important is the epoxy. Epoxy adhesive has very good adhesive strength, but problem is their brittleness. They are not tough. They are not biodegradable. So how to achieve this biodegradability and the toughness? For this, our researchers started to get hyperbranch bio-based epoxy resin. And we have seen that incorporating a suitable bio-based moiety into the system like monoglyceride of castor oil resulted not only highly impact epoxy thermosets, but also it will give you biodegradability. However, all these polymer have been synthesized by conventional solvent bond system. Whereas solvent, mainly organic solvent are used because these are organic in nature, resulted high VOC. So organic solvent are toxic, flammable, odor. Hence, these will not lead to sustainable development. Hence, we have switched over from the solvent-borne system to the water-borne system, where water is used as an ideal solvent because this is not only low cost or easily available, but also these are not generate any VOC. They are environmental friendly, and most importantly, you can clean them easily with using water system. Thus, in our research, we have produced the bio-based hyperbranch waterborne polyester system, where we use citric acid, glycerol as the bio-based system, and without using any external emulsifying agent or some neutralizing agent, catalyst, we have end up with a beautiful environmental friendly polyester system which can produce bio-based raw materials. We have also synthesized different type of waterborne polyurethane system, polyurethane dispersion, waterborne polyurethane, by using again bio-based system, and without any gel formation, we can get this hyperbranch polyurethane structure. However, this kind of system, always you have seen that some petroleum raw materials are used. So our latest research was how to get fully bio-based hyperbranch waterborne polymer system. And in this endeavor, we have utilized dimer acid, glycerol, citric acid, and produced the highly biodegradable waterborne polyester system from bio-based raw materials. Along with this, we thought that why not we can incorporate some special attribute into the polymeric system which are obtained from bio-based resource and having special architectural features. So some smart behaviors, some intelligent polymer we have tried to synthesize. And because this can be utilized for different special applications, like say smart switcher, where this will required to be formed not without intervention of human being or doctors, and they can be biodegradable so that second surgery is not necessary. They may be self-cleaning the surface, say particularly say wall painting. This become dirty within a couple of years. But if you have a self-cleaning paint, auto-cleaning paint, then automatically it will clean and no need of double painting or second time painting within a 3-4 years or even more. Then smart tubing, where there is a clotted blood, can be removed without surgery, major surgery. Minimum invasive surgery will help us to use some special polymer which are known as safe memory polymer. That means they can change to a temporary shape as desired, but after their application, when you need, they can get their own original shape, and that can be useful, just like removal of the clotted blood from the artery or even the pancreas. They are smart attribute like self-healing polymer. We know that if there is a damage or with the passage of time, polymers are degraded, or there is a scratch, damage, breakage. And just an example, say in an automobile system where number of automobiles are increasing day by day, and there is every chance that there may have some minor even damage during where when you are playing or driving. Even though you are careful, somebody else can make this damage. And hence that need to be huge cost to repair or repaint or get the newer one. Whereas self-healing system, if you have a self-healing coating, then this damaged part will be healed automatically without the manual intervention or little amount of applications of energy or stimuli are required to get the completely healed system. Thus, we have synthesized some bio-based hyperbranch polyurethane system, which not only shows the shape memory effect, that means change of shape, fixing, shape recovery with using heat energy or microwave energy, but also it can heal the damaged surface of itself within, say, 58 seconds. And this healing efficiency, if you have seen, that it is very high, nearly 100%, and you can do repeated healing without any loss of efficiency. This kind of polymer also having hydrophobicity in its surface or structure. And if it is become hydrophobic, then surface will become a micro and nano roughening, which help to clean the surface by water droplet itself. And these are also biodegradable, so they will not cause any environmental pollution. However, whatever the architecture, whatever the polymer, whatever the system you use, whether solvent-borne, water-borne, earthen polymer always suffer from low thermostability, high flammability, low mechanical property. That's why we have the proverb that virginity is not the virtue for polymer. You have to adulterate them. And the conventional way of adulteration to make the field system of conventional composite system, where huge amount of reinforcing material you have to incorporate into the system to get the desired performance. And at the end of the day, that resulted loss of transparency, lightweight characteristic, processing difficulties, even in some cases, biodegradability. Thus, even though this was used for long time, more than 50 or 60 years or so, but now the new concept is coming into the picture, and that is the help of nanomaterial or nanostructural material. So if you can incorporate little amount of nano reinforcing agent where conventional system required 50 to 60 parts per 100, it's required 0.01 to maximum 5 weight% nanomaterial, and suitable combination of nanomaterial with the polymer resulted polymer nanocomposite, which having great significance over the conventional field or composite system. And hence we have tried to utilize a number of nanomaterials from one-dimensional, zero-dimensional, and two-dimensional system like nanoclay, multiple carbon nanotube, graphene oxide, reduced graphene oxide, carbon dot, carbon nitride dot, cellulose nanofiber, and different types of metal or metal oxide nanoparticles into our polymer system. A few I just want to mention, just like say this nanoclay. Nanoclay, these are hydrophilic, whereas most of the polymer are hydrophobic, and hence you need to modify them. Now, generally modification is done by quaternary ammonium or phosphonium ion, whereas we have tried to use the different strategy, the inbuilt modification of the nanoclay as well as making the polymer nanocomposite by using polyaniline nanomaterial, polyaniline polymer. Aniline, we know that it is the amine, and if you make the salt, that ammonium salt, and which is required for its oxidative polymerization, then that will not only help in modification or swelling of the nanoclay layer, but also it will produce in situ polyaniline nanoclay composite by polymerization of aniline monomer through the oxidative polymerization process. So it will help to get the nanocomposite within a single shot or at the same time. Now, this multiple carbon nanotube, which is one of the strongest material and used largely in different fields. Now, multiple carbon nanotubes surface is aggregated among themselves and very difficult to interact with the other material. And hence, it's need to modify the surface. Generally, covalent or non-covalent modifications are used. Now, when you do the covalent modification, then there is a problem that degradation of the tube may occur and aspect ratio of the nanotube may reduce, which reduces its efficacy. On the other hand, non-covalent, if you do, then what will happen? The effectiveness of modification will be less, even though its aspect ratio remains same. Thus, we thought that why not a combination of covalent and non-covalent modification, that is, we call them as a fishing approach, that we can covalently link some of the functional groups on the surface and non-covalently wrap on the surface of this nanotube. And in this process, we are getting modified carbon nanotube, which can be incorporated into the polymeric system without devoid or deteriorating the nanotube performance. Our major breakthrough was ultra-fast reduction of graphene oxide by using bio-based system, where most of the conventional system use reduction process of graphene oxide, which is obtained from graphite by oxidative process, modified Hamer's method. And this graphene oxide can be reduced. To reduce graphene oxide, as you know, that graphene is very difficult to produce in bulk scale, and hence it is very difficult to use industrially. Whereas getting the equivalent performance, reduced graphene oxide can be obtained in bulk scale, as well as it can be reduced. It can be used in the industry, and hence its importance is very, very high. So in our research, we tried to reduce graphene oxide by using different type of phytoextract from Colocasia esculenta to nahar leaf, and we are able to successfully reduce graphene oxide to form the graphene oxide just by 5 minutes using a metal and catalyst. And this is highly cited one of our publications. On the other hand, the zero-dimensional nanomaterial like oxygenated carbon nitride dot or two-dimensional nanomaterial like oxygen carbon nitride nanosheets, which can also be obtained through a simpler technique from guanidine hydrochloride and chloride by using autoclaving system or using the microwave energy, which can produce a highly photoluminescence nanomaterial. Our major breakthrough was on carbon dot, which we have synthesized from different types of water-soluble carbohydrate obtained from nature, and this can be converted to the oxygenous semiconductor carbon containing a nanomaterial which have high miscibility or nano-level dispersibility in water and high resistance to photobleaching. It is also non-toxic and highly biocompatible. And in fact, this carbon dot, which are produced in our baking system in food, we are taking almost daily without any effect. Thus, these biocompatible, highly water dispersible carbon dots are produced, which are much superior compared to semiconductor inorganic nanomaterial, because inorganic nanomaterial are mostly toxic, they are not water dispersible. These carbon dot, which are obtained from this carbohydrate just by thermal heating, even a glass bottle can be utilized at about 150 degrees centigrade 4 to 5 hours. If you heat it autoclave, then you will produce highly luminous photoluminescence carbon dot, which can be further reduced just like graphene oxide to reduce graphene oxide to get much more effective photoluminescence and reduce carbon dot. We have also synthesized different types of metal and metal oxides nanoparticle by using different types of phytoextract. One of them says silver nanoparticles, which is obtained by northeastern some leaf extract, thuja, which we have collected from NEHU itself. And these silver nanoparticles having very interesting anti-cancerous property, which we have worked with the Santiniketan with collaboration, and we have seen this silver nanoparticle has high efficacy to kill the cancerous cell without damaging the healthy cell, along with the reinforcing effect to the polymeric system. Now, when you incorporate this nano reinforcing agent, particularly functional nano reinforcing agent of the amount, as I told you, less than 5 8%. Here we have used 0.51 and 2.8% reduce graphene oxide functionalized, and functionalization is done in such a way so that it will become the part of the polymeric system. Here, bio-based castor oil-based hyperbench polyurethane is used, and if you see, compared to the virgin polymer, this system having improvement of almost 5 times, both in strength, toughness, scratch resistance, impact strength, and significantly the elongation at break. All of you know, most of the cases when you incorporate nanomaterial, because they are solid particulates, so they reduce the elongation at break. But in our study, we have shown that elongation break can also be enhanced significantly if you functionalize properly and if you incorporate this nanomaterial into the polymeric system by suitable modifications. And you can see from 700 to 1650% of elongation we have achieved just by 2% functionalized reduced graphene oxide incorporation. Here, that as I told you, that smart attribute intelligent polymer can be obtained from this bio-based hyperbench system, and that can be further enhanced by incorporation of such nanomaterial. Thus, this shape memory polymer we are obtained from incorporation of different types of nanomaterial in this hyperbench bio-based polyurethane system, and where both the fixing of shape and very high with high efficiency and very fast recovery are obtained, which are ultimately used in the smart suturing system, smart stent, scaffold in tissue engineering, and artificial muscle, particularly soft robotic system in our research. Now here I have shown that you can use different types of nanomaterial to obtain different type of shape memory materials. This shape memory or shape recovery can be obtained by application of targeted or contact and non-contact stimuli like heat energy, solvent, microwave, sunlight, so on and so forth. And in our research, we have shown that all such kind of shape memory material can be obtained by incorporation of all these nanomaterial into the polymeric system. One of these such nanocomposite of castor oil-based hyperbench polyurethane with iron oxide and reduced graphene oxide combination nanomaterial, nanohybrid system, which will not only shows the fast recovery of the shape fixity, even it can form a knot of itself by 35 seconds, and most significantly, it can lift its weight more than 1,000 times of its own weight by the using this shape memory system. That thus it can be used in as a artificial soft robotic artificial muscle. The system can also be used to self-heal. We know that animals, some of the special animal or the plant, they can heal themselves, whereas the material cannot, because this is a non-living things. That is the concept. However, recent study and in our research also we have seen that even a material can heal their damaged surface by themselves by application of some stimulus like microwave, sunlight, heat energy, or solvent. And here you can see from these images that when a damaged surface are exposed to microwave or sunlight, they can heal with almost same efficiency, 90 to 95%, and it can be done repeatedly without significant loss of efficiency. These self-healing attributes, of course, depend on what type of nanomaterials you are using and also its nanostructure as well as the presence amount of nanomaterial present in the system. Thus, you can see that with increasing the nanomaterial content, the efficiency is increased, and hence also the amount of energy what you are utilizing as the stimulus, that will also influence the getting the healing efficiency with variation increasing the energy, higher the efficiency. Now, we thought that most of the conventional system of self-healing polymeric system, they use the healing agent externally. So in capsule you have to use, whereas we are not using any additional healing agent. So how it is possible to get healed and repeated healing without using healing agent? So we have proposed a mechanism that in our system that nanomaterial which are used, they act as a nanoscale heater. So when we are applying this stimulus, whether it is microwave or sunlight, they absorb energy and they dissipate into the system. And as a result, this micro Brownian movement of the soft segment, which are flexible segment, are started and they rapidly move forward where there is a damage and heal the surface. Thus, repeated healing is possible unlike the externally added encapsulated self-healing agents. This system of nanocomposites not only clean the surface by superhydrophobicity, but also they help to delay the ice formation. You know that during winter time or winter country where the temperature weather is very cold, they are keeping the instrument particularly or the engine is difficult to make in working condition because of the low temperature and ice formation on the surface. So we have seen that if you coat these super hydrophobic nanocomposites into your device, then it will delay significantly. You have seen 2700 seconds. It's delay the ice formation compared to without using this nanocomposite. And we have in the same surface, somewhere we have coated and somewhere we have kept bare. And we have seen that bare surface ice formation, whereas coated surface, no ice formation was noticed. Thus, this coating of nanocomposites helps to delay the surface because of this super hydrophobic effect, because air are entrapped on the surface and they act as a barrier to delay the ice formation. This help cleaning is also possible to obtain through photocatalytic effect. So we have incorporated some nanomaterial here, zinc oxide and reduced carbon dot are incorporated in a hypervalence polyurethane system. And we have seen that this can be utilized to clean the surface here. We have taken detergent to different kind of detergent, and compared to the state of literature, we have seen that our system, by using only sunlight, you can achieve 96 to 95 to 97% self-cleaning ability of the surface when you apply this kind of nanocomposite system. So this lotus effect are here, of course, obtained from the photocatalytic effect, which resulted formation of superoxide and hydroxide radical by absorbing sunlight by excitation of electron in the reduced graphene oxide or reduced carbon dot system. And that species, that oxide or superoxide species, is so reactive that they can oxidize this dye molecule or detergent and degrade it into carbon dioxide and water system, and the surface become clean.
Hello? Hello?
Yes. Yes.
Yeah, we are running out of time. Please
Okay.
conclude.
Okay. Okay. Maybe 2-3 minutes more.
Yeah, within 2-3 minutes. Yeah.
Yeah. So here I have that's shown a system where without using any solvent, catalyst, or neutralizing agent, we got a nanocomposite where nanomaterial act as a reactant. Carbon dot is used as a reactant, and using this, not only you are able to improve the performance, but also you can get self-cleaning attribute, different color photoluminescence by using different wavelength of the UV light, and which can be utilized in signaling system, auto cleaning paint. And if you incorporate along with the carbon dot titanium oxide, then spectrum of applications will further improve, which will not only give you self-cleaning system, it will also help to get the separation of crude oil and water mixture by help of this membrane, and that resulted repeated separation of water from oil. And these are also biodegradable. There are other kind of biomaterials we have synthesized by using this nanocomposite system, like, as I mentioned, that smart switcher, which can be formed self-knot by within 15 seconds within the body temperature of 37 degrees centigrade. And these are also antimicrobial, and these are biodegradable. This self-expandable stent, when there is a blockage in the heart or the artery or in the binary system, then you have to use stent. Metal stent are very painful, whereas on the polymeric stent, what are used within a couple of years, they are forming biofilm, and hence there is a need of replacement. In our research, we have shown that if you can make a antimicrobial stent, which will expand self almost 99% at body temperature, and they are having antimicrobial efficacy, and hence they will not allow biofilm formation, and hence you can use for longer time. All these material are biocompatible, as we have tested by pathological study, where there is no change in different major organ of a Winster rat, which after post implantation of this biomaterial. Even we are used as a scaffold for bone regeneration by through surgery, or even without surgery by injection inside the where is a damage of the bone. And we have seen that bone formation, new formation of the bone is happening by injectable bone tissue engineering scaffold of our nanocomposite system. These are also used for making 3D system, which are very useful for biomedical scaffold system. And this can also be used to lift some weight, that means act as an artificial muscle. In one of our nanocomposite system is fantastically used as a catalyst, very selective and effective. 100% selectivity, paraselectivity can be obtained by using this composite system, whatever the substituted organic compounds or aromatic compound is there, and always 100% para isomer you will get in hydroxylation of this aromatic compound. All these polymer and polymer nanocomposites are biodegradable, so they will not cause any solid waste disposal problem. However, in case of nanomaterial or nanocomposite, as you know, that there should have some life cycle assessment test, which is a cradle to grave analysis and consists of inventory analysis, impact assessment, and improvement analysis, through which you can design and use the right material and process to minimize the adverse impact to the environment and the health of the living system. So in our endeavor, in our research group has given so many efforts where you can use the material as a anti-counterfeiting, one of the important material where counterfeiting is a very common problem. And you can use this nanocomposite to get or hidden your security system, and you can get different color at different wavelength to get your impression back. You can use them as tough adhesive biosealant. You can use them as a e-pollutant removal, industrial enzyme immobilization, bone tissue engineering, which I have already talked on, and smart material, to mention a few, along with the bio-based super absorbent hydrogel recently we have worked upon. Thus, this bio-based engineered material can give you value-added product for multidimensional, as a multidimensional material for multifaceted applications. Result shows that both the starting material as well as end product are biodegradable, green, and having the targeted sustainability. You can achieve high carbon credit and follow the triple bottom line approach through this approach. This approach also give you environmental clean and with a multifaceted attribute. Thus, this multifunctional polymeric material having the multifaceted advanced applications in different fields. Thus, in our research, we have tried to address the solid waste disposal problem, petroleum feedstock, and VOC generation. This is, of course, different funding agency help us to do all this research, and most importantly, these are the student who has worked for this day and night, and I am thankful to them. And these are the recognition we have received for our research from different corner, both in India and internationally. And take home message from this research, I can tell you that if you can design nanostructural material with proper concept utilizing the molecular engineering and nanotechnology, you will able to get a multifaceted attribute of your material. And hence this material have high potential for different advanced applications. And approach is sustainable, it's required minimum energy consumption, and it will not generate any solid waste for the environmental pollution. And thank you for your kind attention. Over to the chairman.
Yeah, thank you, Professor Karak. Now the floor is open for questions. Yeah, can you come here?
Hello.
Yeah, please.
Thank you for the interesting talk, sir, and sharing with us your beautiful work you are doing. My question is, at the beginning of your talk, you discussed about the high carbon credit, which is the like one of the characteristics for light polymer. So, what is the limit? Like, what is the lowest and what is the highest that should be to be the right polymer to be that has the high carbon credit, and in what unit is it measured? It is
Okay. Okay. Now see, this carbon credit is measured by how you are reducing the carbon dioxide or any greenhouse gases in your process or materials or applications. Now, when you are using any bio-based raw material and using the environmental benign process, say waterborne system, first of all, bio-based system, when you are using, then you are using a carbon neutral system, because for production of the bio-based raw material, whatever carbon dioxide is produced by the plant, that will be consumed during their degradation. That means degradation produce carbon dioxide that will be consumed by the plant, because you are getting it from the plant only. So carbon neutral, these are the carbon neutral. Number two, when you are using the benign process like waterborne system, in a system where less amount of material are used in nanocomposite system, then the and biodegradable system, then you are not generating any pollution to the system. That means you are not creating generation of greenhouse compare or as comparable to the petroleum based or a conventional system. So by this way, you are achieving carbon credit. You can measure this biocarbon content by dating process by using NMR, 13 carbon NMR or 14 carbon NMR, and these are very costly, of course. And in India, we do not have the system, but USA, UK both having this process. And if you want, you can ask them to do analysis, but one analysis is required minimum 40 to 50,000. I hope I have answered your question.
Yeah, one more question is there. Online.
Can you see?
Yeah, can you see some there?
There. From resume.
Hello.
Is there?
Yeah.
One more question, sir, from resume.
I'm not getting the sound, your voice.
Yes, sir. Can you hear me, sir? Can you hear me, sir?
Yeah.
Good morning, Professor Karak. There is question in the chat box.
Yes,
Okay,
sir.
okay. Let me see chat box. Can you read? I am not able to see.
Yes, sir. I will read it for you, sir. There is a question from Refugee Mamato. He says that, is there universal photocatalytic dye degradation experiment?
Okay, I understand.
This is
No,
his first part. This is his first part, sir. When he's saying, is there any different literature photocatalyst that can be compared it with?
as such, there is no universal photocatalytic catalyst which can degrade all the dyes. However, there are some nanocomposite system or nanomaterial system which can degrade both cationic and anionic track. Okay, depending upon the interaction with them. And this is the first one. So universal photocatalyst, if you want that which can degrade everything, it's not.
Sorry, Professor Karak, question is little bit different. Is
Yeah.
there universal photocatalytic dye degradation experiment? Is there so that different literature photocatalyst can be compared?
Okay. Testing.
Testing.
Yes, I should say you should follow the ASTM standard for photocatalytic degradation of the dyes. And this is mainly depends on the source you are using, which means what would be the stimulus? Is this sunlight? Is this microwave? Is this thermal energy? What it is? So if you say all the cases, this energy is sunlight only, then this will be an universal, but that is not there. Okay, because not all the photocatalysts are able to degrade the dye by using sunlight. So as such, there is no universal photocatalytic testing method through which you can do so. However, you can measure your process and see what is the change of, say, for example, dye color change by UV light, and that is considered or accepted across the globe. So by using UV light, you can measure the intensity of the dyes, and with time, by using the stimulus, whatever you want, that if you measure, then that that testing process is acceptable across the globe.
Yeah, thank you so much, sir. One more question is there, sir. Do you believe that bio-based material can potentially replace the petroleum-based raw materials?
Still the research is going on, but I should not say it's completely, but yes, industry is trying to replace as much as possible, but still it is not that 100% we are able to replace it. It's not possible. Even I am not able to discuss on that. I have shown that even if you use bio-based system feedstock, then all the problem cannot be solved. So it may not, means it is rather overwhelming to say that it's completely replaced. No, it cannot replace completely.
Thank you so much.
Any more
Not
questions?
that it is not done. It is in principally it cannot replace completely. Is it?
Yes.
Any other questions? No. Yeah, there is no more question. Thank you, Professor Karak, for your interesting and useful talk and sparing your valuable time for our conference.
Thank you.
very much.
Thank you so much. Thank you, organizer, particularly Professor Jyoti, for inviting me, giving me the chance to interact with them. Thank you so much. Bye.
Sir, for sharing your wealth of knowledge with us. We are enriched very. I will be in touch with you, sir, for further information. Thank you
Okay.
very,
Thank you. Thank you so much. Bye.
thank you very much.